do we have enough at scale? And the second question is, if we do have enough and this will be served, how will this change the generation mix? What are the impacts there on the production cost as different generators will be utilized differently? And are there any challenges that EVs may pose to the grid? So these are the two questions that we addressed from the bulk power level. And we focused on the WEC because of some of the data availability that we had. You're seeing here the balancing areas there of how the grid is being controlled in these 37 different balancing areas within the WEC context. And we picked a study here that was 10 years out into the future. So the analysis, the grid projections were done by the WEC, and we utilized their data for a 10-year out forecasting horizon that placed that at 2028. So we had to adopt some projections there that other people have done, and we looked at EV light-duty vehicle adoption that EPRI has done, shows the high penetration scenario, and there was about 9 million light-duty vehicles in the WEC footprint. So you will hear in a minute national numbers, and this 9 million, if projected out to the nation as a whole, translates into 24 million. Likewise, we looked at medium-duty vehicles and heavy-duty vehicles. On the medium-duty vehicles, 70,000 vehicles that would all come home to a depot charging station. On the heavy-duty vehicles, we assume they are Class 8 trucks. These are long-haul trucks that would not really come home to a central depot, but would continue their travel along the highway system, and we post there 49 fast charging stations, and they are not individual columns or pedestals. Think of those as charging hubs with a variety of different charging stations. So we looked at what are the implications there with respect to this new impact by electrified transportation. And so you're seeing here on the right-hand side the charging profiles that we chose there. You're seeing there the majority of the load comes from light-duty vehicles. That is the orange surface there, and it would manifest itself there in the evening hours at around 2000 hour, 8 o'clock at night, and then superimposed there, you're seeing there mid-duty in green and heavy-duty in yellow. So the biggest impacts in the next 10 years we're expecting from light-duty vehicles, but that's not to say is that mid and heavy-duty vehicles may pose some challenges. However, they will be more likely in the distribution system. Next slide. So here are some high-level answers there to these two major questions. And can we, yes. Here they are. Is do we have sufficient resources there? And the answer was yes, under normal conditions. So we've been asked, what does it mean, really normal conditions? And normal conditions are really sort of average load condition. You have a heat wave, neither does it mean you have major fire corridors and you would need to deactivate some of the lines. Those are contingency scenarios that we in this particular study didn't address, but I can tell you that it would impose a great deal more stress conditions. So this is for the normal case. If all of question, all right, so if you really want to push the electric vehicle adoption there, how high can you actually go? From 24 million light-duty vehicles, which again for WEC footprint is 9 million. How high can you go before you encountering some bottleneck issues? We actually could go to 30 to 37 million vehicle. Again, that is for the entire nation. If you do unmanaged charging, the way you just saw on the right-hand side, this load profile, if you do managed charging with some smartness involved in it, you can actually double it. And that's a key insight. That's a real key insight. That managed charging, if you move the load there, can avoid upgrade of infrastructure. Next slide, please. So the next question is operationally, what would change cost-wise and which generators will be used? So on the production cost, we're pushing the margins there, particularly California, all the way along the West Coast, as you saw, is that's where the penetration of electric vehicles is expected to occur the most. And you're seeing there that peaking units will need to be utilized there, and that drives up the cost. So those are costs on the margin. So that's a marginal cost that we evaluated. And so they range anywhere from 3% to 22% in California's case. The question is, so, and it's particularly of interest there from an emissions perspective, if you look at the net balance of emissions as you're reducing the greenhouse gases and the criteria gases from trucks and vehicles to the grid, what would be the net benefit? We looked at first at the generation and recognized that the available capacity that would be utilized for the vehicles would be primarily natural gas fired generators. CC here is combustion turbines. CT is combustion turbine, CC is combined cycles. So they're on the margin. They are the ones that will contribute the majority of the new electric generation that will end up in the vehicle's batteries. As far as evening charging, as you saw there, that exacerbates the stress there. It sets a new system peak and exacerbates the duck curve in California. And we're seeing it also in other areas, that is to say the duck curves, where you have a lot of penetration of solar technologies. So EV in general has a very positive effect on renewables curtailments because it adds more load, regardless of when you charge and where you charge it. But it's particularly helpful if you move it from the evening hours to the day hours. That is where the renewable curtailment would be minimized. Next slide, please. So after quantifying these we're now going to the last mile of the delivery system in the distribution system. And we asked very similar questions there. Where, when, and which EV there would impact the grid the most. Unlike in the previous study that you saw, is where we have a finite set of data to make a region analysis. This is very, very difficult to do for distribution system because every circuit is different. It's different with respect to the vintage in old town infrastructures. They are designed about 100 years ago, totally differently, without recognizing there will be some air conditioning later on, and certainly not having in mind that electric vehicles will materialize. So design characteristics that went into these circuits are different compared to more modern neighborhoods that we're seeing. The composition of the customers, commercial versus residential, is different, setting different peaks. And so every circuit and every feeder is different. And so we asked the question more, what would be the right set of tools there that we could enable the community of distribution planners to actually do these impact analyses? And these impact analyses are actually can be further defined there as EV hosting capability. If you know the EV hosting capability of circuits, then you can make the capital investments to say, look, I I can put in my investment plan upgrades of secondary transformers or upgrading of conductors or changing some of the voltage control assets. So the outcome of this is, and this is we're currently undergoing this activity. The outcome is really setting up a set of procedures there that other people can adopt. And so what does it consist of? It consists of, first, a penetration model. That is a high granularity EV penetration model for light duty vehicles with which you can project how many vehicles will be in neighborhoods. You have to bring it down to the neighborhood level, actually to the circuit level, to be relevant for distribution planning. So these larger numbers there by counties or by states are insufficient for the distribution planners to say is, where will these electric vehicles be? So it needs to be at a higher level on the map to be of use for distribution system analyses. And so then questions are, is if you do reach in 5 years or in 6 years or in 8 years capabilities, A, where will it be? Where in the circuit will it be? And then what are the mitigation strategies? And there are many mitigation strategies. Managed charging, smart charging could be one, but it could also be other non-wireless solutions such as batteries behind the meter or photovoltaics behind the meter or in front of the meter. And so we will look at all of these different strategies. Right now, as we're doing this study there with Southern Cal Edison and DT Energy, but we're also inviting other organizations, utility organizations to join. And the level of engagement here is, or the hurdle of engagement is, we need to have very detailed data on distribution system. Next slide, please. So this gives you an overview of what this analysis may look like. So we used some feeder data. This is sort of the topology there, the large formers, and then you have dots here of homes. Our penetration model, EV penetration model, will say is, look, what is the propensity of individual neighborhoods and homes having an electric vehicle? And we place these vehicles, if you can go back one slide, we place these vehicles then on the map, do our power flow analysis, and then look for bottleneck situations. As you can see, as a function of penetration, you see it here in the green bubble. So you're seeing here a load load predictions there that at some point at the penetration rate there will be an exceedance of, in this particular case, thermal rating. And then the question is, what are you going to do about it? And there are different strategies that we will pursue, such as smart charging, as you see in solution 1, or simply the old conventional method of upgrading the feeder. We'll look at cost minimization strategies to look at the best solution there based on value and cost. Next slide. And this is where this is finishing up here. My set is, so what are some of the questions there that people have asked in the past on the bulk power system is, so from a policy perspective is, do IRPs study look far enough out into the future? We've seen that utility companies are looking 10 years out and they don't really see much electric vehicles. If they're looking out 20 years and with the newest targets there of their states there, they may actually see quite a bit of load. So the question is, are you looking far enough out? What's the right wholesale market rules there to create incentives? Smart charging is always being asked there. So it's, how can you encourage smart charging just from a bulk power perspective, just to use the right generators to address the duck curve, which are quite of concern for grid operators. On the distribution system is, retail pricing. So you get these bottleneck situations, and if you move the load to a different time slice in the day, or if you have alternatives for somebody to charge at work, what's the flexibility of your electric vehicles, and how can you utilize this with the right retail price signal there or rate schedule? There's challenges there with a charging station and minimum technology requirements to make them future-proof. Again, has something to do with fast charging, with standardization of charge management, particularly for the ever-increasing faster charge rate because of the growing size of the batteries. And then how does it compare smart charging with all the IT to be placed now versus feeder upgrades? And these are some of the challenges being discussed. On the market adoption is what's the right incentive signal for EV adoption and charging infrastructure, and particularly under the lens of equity. Fairness there, that's the big item. Disadvantaged communities there, how do you incentivize the adoption of electric vehicles there? And with that, I want to stop. Thank you.
Thank you, Michael. That was a great overview and a great way to get this discussion started. You really articulated, I think, some of the questions about going forward with a electrical infrastructure that's organic and reactive and always built for rush hour, versus one that's planned and predictive and always is looking for the best price and to manage cost in a just-in-time inventory system. I look forward to discussing more of that during the Q&A with our folks participating here today. Our next speaker is another great expert. We have with us Annie Schneider, who is the Senior Transportation Program Specialist for the Utah Governor's Office of Energy Development. Annie will be discussing Utah's efforts related to EV infrastructure planning and deployment, and how the Utah state offices interact with local utilities in order to promote a resilient, effective energy system. Annie, go ahead, the floor is yours.
Hello, everyone, and thank you for that introduction, Jeff, and thank you to the Western Governors Association for this opportunity to present on today's webinar. For those who don't know, we have undergone some leadership changes in Utah in 2021, including welcoming our new governor, Spencer Cox, as well as his new energy advisor, Tom Carter. And Governor Cox's One Utah Roadmap, which details the priorities of his administration for the first 500 days in office, emphasizes the importance of continued investment in EV infrastructure and particularly in rural Utah. So if we could go to the next slide. Our current EV market looks a little bit like this. So pictured on the left is Utah's publicly available DC fast charging network. The green dots indicate 55 locations where there's 142 DC fast charging outlets. And that's a number that I'm very happy to report has grown over 10% in the past 3 months. And also, just as another component of the infrastructure that we have in the state, we've got just over 1,000 level 2 charging outlets spread across 345 locations. And on the right-hand side here, you can see a graph of Utah's EV registrations for passenger battery electric vehicles. And so earlier in 2020, there were just under 8,000 of those vehicles registered. That's still going to be less than about 1% adoption. However, we do anticipate that that number has grown in the past year, but are still kind of waiting to just see by how much. But you know, if this exponential trend continues with how many registrations we've seen in the past 5 years into the next, it's very possible that we could have over 50,000 EVs on the road by 2025. And that might not seem like a big number in the grand scheme of things, but that is certainly a significant jump from where we're at now. So it's really important that we are coordinating about the needs for this market from a state perspective. And, you know, all trends are really pointing to more EVs, probably more rapidly than have been expected in the past. So the question now is, what can Utah do to advance EV infrastructure while also maintaining a grid to support the future growth? And so to answer this, we're going to need to address some of the complexities that come with building an infrastructure network. So if we could go to the next slide. The first challenge that we are going to be faced with is expanding EVs and kind of how we're going to fund all of that. And the solution would be to find different funding opportunities that come available either through state funding, federal funding. And so some things that we've worked on so far from the state side of things, our state legislature has funded a few different EV programs, both for state facilities specifically, as well as a larger grant program for businesses to apply for workplace chargers. Those have primarily been level 2 charging, but for some of the more expensive DC fast charging stations, we have been using the VW settlement funds, and those have been installed at a lot of the more remote locations in the state. So if you see some of those more isolated dots on the map, mostly on the right half of the state, that's a lot of it is to thank for the VW settlement funds. And then we also have a number of utility programs that have been really successful in the state. The largest investor-owned utility, Rocky Mountain Power, was awarded a grant from the federal government that allowed them to expand EV charging across their service territory. So we were really grateful for that opportunity, which allowed for a major build out along the I-15 corridor. And they also just manage a number of incentive programs as well to just assist with additional chargers being built again across their service territory. And the state has been really strategic about where these chargers are being placed, since typically the funding mechanisms have been tied to either a specific goal or a certain type of applicant. So, we've been really thoughtful in this process. And if we could go to the next slide, just from kind of that dispersal of funding, you can see that we really have a lot of cooks in our kitchen. And the next challenge that we're faced with is, how can we possibly keep all of our stakeholders coordinated? And the solution for that is to encourage partnerships and working groups. So from the state partnerships that we've made, we have a state working group that's been established, which is composed of a lot of the key agencies for just EV infrastructure, whether that's, we've got the Energy Office, the Department of Transportation, Department of Environmental Quality, Tourism, Facilities and Construction Management, State Fleet. There's a lot more, but don't have time to go over that. But we also have sought some guidance from external partners, and the biggest partner is definitely going to still be the utilities. And so this map in the middle shows the service territories for all of the utilities operating in the state of Utah. So you'll see that darker blue shading, that's going to represent the territory for Rocky Mountain Power. But these other utilities are absolutely a vital part of the infrastructure build out. So we've been working to coordinate more with them in some of the rural developments. And we also partner with our universities on kind of all research related to electrified transportation. And Utah State University in particular has been really leading out on a lot of this research. If you can think of any topic pertaining to electrified transportation, they're probably working on it through their engineering research center called the Aspire Center. So they've been a great partner, as well as our Clean Cities Coalition. They're a really great resource that we have in the state for connecting with industry representatives, as well as some more local partners. And then from a regional perspective, many of you on this webinar may already know, but Utah is part of the Regional Electric Vehicle Plan for the West, or Rev West. And we have found that collaboration to be very helpful as we roll out some programs and understand best practices that have worked in some states, and can also just kind of share concerns being faced across the region. And so with the background on all of these different groups, all of the funding, the final challenge is, how do you kind of put all of that together and make it strategic enough to, stand the test of time? And the solution is to create a plan. And so on the left-hand side here, you'll see the second edition state EV plan that was developed last year. We've already got a third that's in the works already and should be released in the near future. But Utah's taken the approach that we really need to be collaborative and working with all different types of partners about building this infrastructure network. We're not taking the approach of kind of throwing darts on a map and just installing chargers wherever they land. So we've found this to be a really successful process, and it's allowed us to not be very duplicative in our efforts of trying to roll out chargers across the state. So if we could go to the next slide. So just in summary, if the state continues to collaborate on future EV infrastructure developments, we'll be prepared to face the growing EV market. And kind of my advice to the audience today is just to be proactive about this and encourage more charging infrastructure in your states. And you can do that through collaborating on EV funding opportunities and just building partnerships to have a really informed stakeholder network overall. And then I've got one more slide just with my contact information, and I'm available to follow up with anyone if they've got additional questions.
Great, thank you, Annie. It's great to learn more about all the interesting EV infrastructure projects and partnerships in Utah. I think in particular, the partnership piece where you've had such a strong consultation process with different stakeholders of that EV infrastructure system, from customers to utilities, it's really impressive. I'm going to turn now to our final speaker. We have Kellen Schefter, who's Director of the Electric Transportation for Edison Electric Institute, also known as EEI. EEI is the association that represents all the US investor-owned electric companies, and Kellen leads EEI's transportation electrification efforts, including policy advocacy, business model development, and cross-industry coordination. I'm looking forward to learning more about how EEI's members are integrating electric vehicles and charging infrastructure into their grid planning and investments. Kellen, take it away. The comm is yours.
Great, thank you, Jeff. And also I want to extend my thanks to the Western Governors Association for pulling this forum together. I think this is a really exciting topic for us and a great set of speakers you all pulled together here. So as Jeff mentioned, EEI, we represent the investor-owned electric companies in the US. And so I wanted to show our member map here just for the audience to familiarize yourself. So these are the companies that make up EEI. And so for the Western, part of the U.S., you can see who those companies are. A lot of the big household names that you're familiar with from our industry. I think the one thing I want to point out here, just by way of sort of context, is our members are making a lot of really stellar progress on adopting clean energy into the power system. 40% of the electricity in the U.S. comes from non-carbon emitting resources today, and our members in particular are on a path to reduce CO2 emissions by 80% from 2005 levels by 2050. And we're really proud of that fact. We're seeing more progress in electric power sector emissions than any other sector of the US economy. And particularly when you compare that to transportation, that's why we see such a huge opportunity. The quicker we can connect transportation to the electric grid, the more progress we can make in decarbonizing the entire economy. And so that's really the opportunity we see here and why we're so excited to be talking about this topic. So on the next slide, and I think Michael did a great job of sort of describing the bulk power system in the US. But I wanted to just help define terms a little bit here. So I think people are generally familiar with the energy grid, taking power from large generating centers, whether that's a natural gas power plant or a solar farm, transmission high voltage across the country or long distances generally to the population centers. And then the voltage steps down and gets into the distribution system, right? So when Michael is talking about bulk power, he's talking about generating stations and transmission. Distribution is where it gets a little more complicated and I think a little more interesting in terms of the challenges and the opportunities when it comes to EV charging infrastructure. So looking at that lower graph, or that lower diagram, if you think about the distribution system, then getting to the customer facility, this could be a gas station that wants to deploy DC fast charging stations. It could be a fleet depot that wants to charge fleet vehicles. Generally, this is what we talk about when we say charging infrastructure. So this is the utility service connection that brings power to the facility. And then it's everything that gets the power from that meter to where the actual vehicle is going to park. And that can be a lot of the cost associated with charging infrastructure. That involves often digging up the parking lot, or trenching and laying conduit, laying concrete. A lot of work and cost involved here, and that's where we see a lot of our members helping out to offset some of those costs, or perhaps even owning and operating some of that themselves to remove some of that cost from the ultimate end use customer and think of that as an extension of the electric grid. So just wanted to help put that in context. When we talk about charging infrastructure, we can talk about those big bulk power impacts, the distribution system impacts, but then also what are those impacts at the individual facilities where customers want these charging stations to be. So just on my last slide, and then I'm eager to get into the conversation here. Just want to leave with a few key messages. Again, clean energy to us is the big motivating factor here. We see huge progress being made on the electric power generation mix, a clear pathway to make major reductions in carbon from the power sector. And so really, how do we extend that progress to transportation is a key role that we all have here to think about and what we're really excited about. So when it comes to what that electric company role is, again, deploying the infrastructure to solve that last 50-foot problem from the grid to the charging station is a big part of what we're looking at helping to solve. But it's also, as some of the other speakers mentioned, about expanding access and helping to make sure there is a minimum viable network of charging infrastructure out there to prevent there being a barrier to adoption, whether we're talking light duty vehicles, medium duty vehicles, heavy duty trucks. And then grid integration, and Michael alluded to this very well, we see that as a key role, making sure that when this load is being added to the system, it's done in a way that minimizes cost and actually maximizes benefit for all customers. And so my final point here, and I'm looking forward to getting into more of this in the conversation, is collaboration really is key here. The energy grid is dynamic and evolving. I think we'll see a lot of investment in transmission and grid infrastructure just due to the increasing level of renewables and modernizing the grid in general. That's all happening separate of transportation. Transportation is just a new factor that plays into all of that. And thinking about how that all plays together is really important. But particularly when we get to this distribution grid impact question, stakeholder engagement is going to be really key. I think we see big gaps potentially in the visibility that our members have into what customers are going to be doing, how they're going to be adopting EVs, how they're going to be using them. Particularly when we go look at some of these heavier duty trucks, which will have potentially really high power needs. How do we plan for that to make sure that the distribution grid is there where the customer needs it, when they need it, and that our companies are not the bottleneck to deploying this? I think that's a key challenge for all of us. And it's actually really requires, I think, collaboration with customers, with state officials to make sure this all gets to where we want to go. So with that, I'll hand it back to the host. Thank you so much.
Great. Thank you, Kellen, so much for that great overview of AEI's outlook into this important policy discussion. We're now going to go to the Q&A part, and I'm going to start out with a few questions, but I just want to remind our participants that if you have a question, please submit them via the Q&A function. Kevin Moss from the great staff at WGA is going to be looking at those questions and sharing them with our panel here. But to start off with, I'm going to have a couple of general questions. And Michael, I'm going to start with you. And I was wondering if I could get you to elaborate a bit further about some of the missing tools you mentioned towards the end of your presentation. In particular, I know for the stuff that we do at Schneider, we are focused on optimizing behind the meter for customers, but there's no interface for us to work with the utility to help them optimize. And then at the wholesale side, there's some missing tools to even compare what might be a value at the wholesale versus the retail. So just to kind of wrap that up, it seems like one of the technology gaps is there's no technology tool that reconciles the conflicting signals across the generation and transmission, distribution, customer value chain. So I'm just wondering if you can talk about the tools that you're excited about working on at the lab. And you mentioned partnering with utilities like EEI's members and with states. You know, some of those tools in particular that the lab's looking at developing or fleshing out further.
Yeah. So as far as tools are concerned, I think we research organizations such as ours, universities and consulting companies are trying to raise the bar, particularly now that we have so much more data available, and looking at new methods of data analytics to do more predictive what if scenarios there, to look much more precise scenarios, really the limiting factor, and how do you improve the utilization and the economic efficiency of our entire infrastructure things. So just to name a few there, it's predictive analytics using real data to say what if scenarios, particularly in the distribution system. We see so many moving parts. So electric vehicles is one thing, but you mentioned there before is looking at utilizing the flexibility that you have in buildings, utilizing the flexibilities that we have there in industry, such as a big organization as Boeing or other big industrial campuses have a lot of flexibility to schedule their load, to schedule their processes. And how do you harness all this? Meanwhile, people go out and buy photovoltaics for their rooftop. Tesla is offering behind the meter storage technology. And so there's an awful lot of degrees of freedom there to address sort of the smart grid evolution. And the question is, what are the right tools? And I think the tool development is being pushed forward, and it's basically utilizing these degrees of flexibility and putting an economic value on it, so that you can identify what is the value in a particular location at a particular time. So this whole valuation becomes much more location specific, where you are in the infrastructure, as well as time specific. What time of the day you're in, what day of the week, what season you're in. And so that is being pushed forward, but it's difficult. I mean, there's the human element in it. It's difficult to operate. And I think there's an awful lot of training that's necessary. You mentioned, well, I want to leave it at that for right now. So it's a big lift, particularly in the distribution system.
Great, thanks, Michael. And Annie and Kellen, you know, having worked with both your members, Kellen, over the years, and Annie, obviously, with state policymakers, you know, it seems like that plan and predictive uptake element, the analytics that Michael talked about, is just a huge missing tool for both of your folks that you work with every day. I mean, if it's one of those, if you build it, will they come questions, right? I mean, right now, some people have said that Amazon may know more about what chargers are being shipped to what utility in the U.S. than the utility does in some circumstances. So, you know, just if you want to speak to what you see as missing tools in your work with both your members, Kellen and Annie, with the state of Utah, about, you know, is it analytics about uptake rates for EVs and where they're going to go? Getting back to that planned and predictive versus organic and reactive juxtaposition.
Yeah, I'm happy to start with that, Jeff, and it's a great question. And I think it's worth separating out some of the use cases here. So if you're talking about light duty vehicles, this is a very much a situation where it's millions of individuals making individual decisions, right? And so that is where some of this predictive modeling, I think, makes a lot of sense, right? Where are the neighborhoods where this is likely to go? What's that pathway of the EV penetration over time? You can make some maybe large scale predictions about that. I would say those tools are getting better, Jeff. I'm not too familiar with precisely what individual tools are being used, but I know, for example, you know, with smart metering out there, you can see see a pretty clearly defined, fingerprint of an EV charging station at a home now. And you can probably predict, even if you don't know that that driver has registered, with the utility as having an EV for an EV program, maybe it looks like their charging behavior looks like they have an EV at home, and you can start to predict some of that stuff. I think a different use case where I'm a little bit more concerned that I alluded to is around maybe warehouses, shipping facilities, the FedExes and the Amazons of the world who are doing delivery stations. Those on the system today look like a very low energy user, right? They just have a parking lot, maybe a building with some lighting and HVAC. If they adopt hundreds of delivery vans, for example, they become a very large energy user. And what is the predictive tool for that, right? That isn't necessarily something that we might just guess from a modeling exercise. This is going to be a few very large customers making decisions about where they place those vehicles over what time period, based on many different factors other than power. And so that to me isn't so much a predictive modeling or tool exercise. That's more of a figuring out what these customers are doing and making sure that they're working with the utilities as they're planning for this, right? And I think we could talk about more how state policy, and Annie, I'm curious what your thoughts around what the role of this state is in helping to make sure that these plans are coming together in the same way. But those are two very different problems in my mind to solve. That's kind of how I'm thinking about it.
Yeah, definitely. I'm kind of looking at this question like, as a state representative here, that we are just kind of looking into a crystal ball. We really don't know what the future holds. Our best guess is based on, quite honestly, a lot of the modeling that, Michael, you've been working on and things that are coming out from the Department of Energy. I mean, we really don't know what the future holds. So as a state, we need to make sure that we're not maybe putting in policies that are too ahead of their time or too restrictive on anything, because that might stifle development, and that's not what we're trying to do right now. We really need to still just kind of build a backbone, because we are hoping to build it and then have the drivers come, use the infrastructure. But when that happens, and when we need to upgrade that type of infrastructure, that's, I would love to have more, just a better estimate of how many vehicles we can expect when. So it's a little tough, especially, being a state that's kind of in between Colorado and California. We really don't have, quite the same policies. So our big driver for electric vehicle adoption is just our air quality. And that is something that has improved over time, but we do see that more people are, buying EVs because they want to do their part for the air. And I think that just kind of following just the trends that we're seeing across the nation, across the West, have been really helpful to understand, what Utah can expect going forward. But it is just, any kind of modeling that can help us identify maybe, Michael, like you're saying, with, there's specific neighborhoods, specific areas where the market is really going to take off. And if we can pre-identify that and just be more strategic in the local distribution network planning, I think that would really be helpful.
Yeah, just to segue this back to Michael before we go to, I see we have some questions in the queue, but Michael, it's not just optimizing on the circuits below substation or substations on circuits to meters, but also it's looking at where you optimize putting some of the like heavy duty truck charging, right? Putting that on the end of a weak end of the distribution system versus somewhere near one of the major AC feeder lines into an urban area might be a lot better location to put it. Just like putting, if you have a bunch of teachers driving EVs to schools and there's community solar at the school, that might be a better value optimization than trying to chase that load around all day. Can you speak to those types of dynamics in the work you're doing?
Yeah. So thanks for this question there. It's addressing some of the needs that we're seeing actually happening within the transit authorities folks, because they're incentivized or mandated to really electrify their bus fleets. And most of them are in coastal established urban environments there with old downtown bus yards, and they like to swap out diesel with electricity. And there's no such thing as fueling up electrically all of the buses in the yard. There is not enough capacity there. And so the question is, where do you place it? Where do you place it to make it feasible? And so there is tool development going on and some modeling that looks at what are the needs from a transportation perspective as one layer, and what are the availabilities of the grid on the other, to really find some optimum. And it's all about constraining or unconstraining the system. Could you nudge the schedule, the bus schedule, to meet all of your commuter requirements and the requirements of travelers, with so the availability on the cables and the availability of a capacity. So this is in congested areas, and I think the Department of Energy is looking at development of new tools, and it does two things there. It simulates the transportation needs from a fleet owner or from entire metro area, and then looking at what are the availabilities on the electric infrastructure and where are some bottlenecks. Where we either need to improve the grid to really open up sort of a charging hub, for shared rides in certain areas where you have not necessarily trucks, but light duty vehicles like the Ubers, all electrified. So this is coming. So it's sophisticated analyses. It means that the grid guys need to talk to the transportation guys. They're still siloed, and there has to be communication between these two communities, but that's happening now.
Thanks so much, Michael, for that. Kevin, I see we have some questions in the queue. Can we take some of those if you're ready?
Sure. Yeah, Jeff. Michael referenced one of these. He responded individually, but I think it's a good one for both him and Kellen to respond to. So and this comes from an employee at Daimler Trucks. And so they ask, are markets with significant EV penetration and time of use rates seeing demand spikes when the lower time of use rate takes effect? And what steps are utilities taking related to this issue? And they ask the question both in a residential sense, but also if there are any applications for fleets or commercial EVs. So maybe, Michael, we can go to you and then see if Kellen has anything else to offer.
Yeah. So I think there will probably be two approaches. They can be joined at some point, but we're already seeing on the light duty vehicles, San Diego Gas and Electric during the early phase of EVs, they really saw as time of use rates, and all of a sudden everybody in the Leafs and the Teslas and the Chevy Volts set the timer there right on the hour when you switch from off-peak, from peak to off-peak. And what do you see is, you're seeing is that the EV load all spikes up and then comes down. If this is at scale, that would be hurting sort of the infrastructure. And so what you do is, you have the ability with time of use to really mold your EV charging load, but you don't want to have it all jumping. You want to diversify the load so that they come on in 10 minutes later. So GM actually developed a technology that, rather than saying is, tell me the start time when the switch occurs, the start of the charging, they actually turn it around and said is, by when do you need to be done? When do you actually want to have and so if you turn this around by simply saying charge by, say 6 o'clock in the morning, then the onset is basically computed by the vehicle based on how much charging it needs to be done in order to get a full battery charge. And so now you're randomizing the onset of the charging based on the level of your charge in the battery. And so that was a very clever way diversified. So you can do the same thing with the onset by simply having in the vehicle a randomization that randomizes over 15 or 20 minutes or half an hour. On the truck side, I personally feel, and the jury is still out there, but you need to actually control it by the vehicles. And I think there's an incentive by the big fleet owners to avoid the big demand charge, because they are now in a commercial a rate schedule category with a demand charge, and they don't want to really set a peak there, sort of a super peak, because the vehicles all start charging at the same time. So they want to smear it out. They want to orchestrate that charging event there over time to minimize the peak. And so it's in their best interest. And so I would assume, and there are already companies out there that do third-party charge management. So they either go, in most cases, they go through the telemetrics of the vehicles to determine the onset. So they have trends, they have observability of 100 vehicles, they know where they are, and they basically manage the load for that account. Now, on the very fast charging stations, for instance, on these big hubs that we're anticipating, where a pedestal can dispense as much as 2 megawatts for big Class 8 trucks, we either see is there will be some internal load management that will be done from a utilities perspective on the supply side rather than on the vehicle side. But the jury is still out, but it's recognized as that control of these fast charging vehicles and stations will need to be done.
So I just want to draw out a little bit further, both for Kellen and Michael. I think one of the fine nuances in this area is when a lot of policy is being talked about vehicle to grid integration. A lot of times it's just, there's some presumptions in some places that's one-way communication from the utility to the EV, wherever it's charging at, about it's okay to charge depending on the time of use and demand. But what you described, Michael, is more around some of the transactive energy work that some of your partners at the lab are overseeing, and really, I think what another point of view is that you got to have a complete vision into both price signals and uptake to make a system work. So Kellen, have you seen any examples of that two-way communication amongst your members that are good examples to call out? And Michael, can you just talk a little bit about that transactive market nature and how that really is kind of the linchpin of a dynamic market, a dynamic electrical grid?
Yeah.
So Kellen, why don't you go first?
Sure. Yeah. I would approach it in terms of actually thinking about the customer in this, the end user, because I think our priority is to make sure we have we electrify transportation as quickly as possible to decarbonize transportation and benefit from the clean energy that we're delivering, while also creating the path to make sure that this is all managed in a way that is beneficial for the grid and all customers of the grid, right? Like that, those are the key things that we're trying to accomplish here, and we need to do them in parallel. So when you think about the opportunities with light duty vehicles, we're going to need a lot of tools here. Time of use rates, I think, are great. I think even in California, we're seeing less than half, maybe a third of EV drivers are on a time of use rate. So that means the bulk of the EV drivers are not getting a price signal yet from the electric company on when and where to charge, right? So we're pulled multiple levers here. The time of use rates is a key component. We may need some more sophisticated demand response style programs where the customer isn't even really having to think about it. Maybe it's going through the automaker as an aggregator, for example. Maybe the signal goes to General Motors and then to the car, not directly to the individual car, as one example. And so we are seeing some examples of that, Jeff. So, there's a really cool project that PG&E did with BMW, which was a demand response style program. The signal went from PG&E to BMW out to 100 EV drivers to throttle the charging, right? That could be something you do in parallel to a time of use rate, for example, and still get some additional nudges, like Michael was saying, on charging behavior. I think, again, when you talk about these larger loads with medium heavy duty trucks, again, I'm thinking of the customer here. And I hear all the time from our friends at Daimler, who I know are on the call, and others, big fleets are used to buying diesel by the gallon, right? They're not used to having to think about kilowatt hours, kilowatts, time of use rates, coincident, non-coincident peak. It's a super complicated thing to figure out. We need to do what we can do to send price signals to make sure the grid is being used efficiently. But I am concerned about how these customers are going to respond to some of these complicated transactive energy style of schemes that we could come up with. And that may be more of a role for like a Schneider, or again, an automaker sitting between the electric company and the end user. Don't let the fleet have to worry to figure that out, because that's not how they're used to procuring diesel fuel today. But someone on their behalf is kind of managing this for them. I think some of these large, sophisticated customers we're talking about here will figure that out, right? Like the Walmarts, the Amazons of the world, they want to be least cost customers. They want to get all the price signals we can give them. They'll figure out the fleet management around that. Some of these small, medium-sized fleet customers aren't going to maybe want to deal with this, and we need to serve them too. And I think we need to think really carefully about how we get price signals in a way that are still useful as a vehicle fuel, which is ultimately, again, we have to keep that in mind. Primary purpose of an EV is transportation. Secondary is thinking about how we can make sure it's useful for the grid and all customers.
Yeah,
Thanks,
I agree with
Kellen.
you.
Michael?
I agree with you. I think you will see a new ecosystem there of fairly smart consulting companies and third-party providers that do the hedging, the same thing that we've currently doing on the diesel and fuel side. They're doing this on the electricity side. It's a different company probably that need different skills. As far as sort of the underlying information is concerned, as I mentioned there before, is we're getting much more observability of what's really happening in the grid. And some jurisdictions, such as New York, are already conceiving sort of systems operators in the distribution system, very similar to what we do there with the bulk power system, where you have offerings there, where you have demand offerings and supply offerings, the supply offering in the distribution system could be that you dispense the electricity out of your Tesla behind the meter storage unit, or you're doing demand response and the excess photovoltaics gets moved into the grid. And so some of the market mechanisms that undergirds some of this technology coordination has been experimented with at our laboratory. We call it transactive energy, where every participant in the grid, whether it's consumer or offerer or prosumer, producer and consumer, can offer up a service to the distribution system coordinator. And so this could be dispensing electricity. And so what you're getting there is really a locational specific marginal cost of the electricity being supplied to a particular node in the distribution system. Very similar to how the California ISO, the New York ISO, New England ISO works. Or ERCOT in Texas, locational marginal price. And so if this is revealed, if this price formation is revealed, then it is exactly the price signal that these smart charging concepts would really thrive off of to really lend themselves toward optimization. Right? So if you understand what's the flexibility, you have a time window for dwelling time of a truck that is 3 hours, or maybe only 2 hours. When do you charge? And particularly if you have even options there of moving around, and particularly when we're talking about automated vehicles, right? Autonomous vehicles, where you have dwelling time and whether it sits somewhere or you move it around to a charging station that is 2 miles away, it's a different service territory with different rate structures, happens to have access capacity there at low prices. You just simply move there to fuel it up or to charge it up and to come somewhere else. So there's a whole new paradigm of technology-enabled market mechanisms that we're anticipating. And it's just beginning.
Great, thank you, Michael. Kevin, I think I saw a question in the queue directed at Annie. Do you have that one handy?
Yep. Yeah, so Annie, there was one question about whether the state of Utah has explored EV charging infrastructure siting in federal lands, so National Park Service, Bureau of Land Management, U.S. Forest Service, and then the question also talked about truck stops. And so I'd just like to add about, what are some of the grid infrastructure considerations with those sites, given that a lot of those will likely be in rural communities.
Yeah, absolutely. So I would say right now, the thought of getting to an EV, getting from the Salt Lake Airport to a national park is really what we're trying to do. We have a huge ecotourism industry in the state. We've got 5 national parks. There's a lot of federal land to be explored. And yes, some of that is very rural, very remote. Honestly, some grid connection in that area of the country is limited already. So the thought of trying to find, a suitable option maybe at the destination is something that we're looking more into. But in terms of getting there, that's absolutely where we're prioritizing our fast charging stations to be placed. So then people who, in their head, they don't want to buy an EV if they can't get to Arches National Park. And now they can do it. So, it's once we stop having people make these excuses and about, their range anxiety, once that kind of is dwindled down, then it really comes to, what's holding them back now. So definitely connecting to some of those destinations is something that the state's looking to do. In terms of like a truck stop, rest areas, things like that, we're also looking at, how we can just expand EV infrastructure there, not only for passenger cars, but, we do need to be thinking a little bit more long-term about heavy duty vehicles. And, like it's already been said, if there's multiple heavy duty vehicles kind of trying to charge at the same time, it's really going to cause quite stir on the grid. So none of that planning should be done in a vacuum. It's really something that we need to be thinking about more strategically from just a future of the grid planning. Because again, a lot of these locations are in really rural destinations. It probably took, 50 plus miles to get there from the last charging station. And there's really not a whole lot else out there. It might just be a gas station and no real town. So it's been definitely a challenge, but it's something that we absolutely need to try to overcome, because that's going to be kind of the crux of reducing the range anxiety that so many people are feeling.
Kevin, is there another question in the queue?
Yeah, we have a few more. One is actually just from a municipal government employee, and they were essentially wondering, this conversation is, certainly not at a 101 level, and they were just wondering what sorts of resources you all recommend for municipal government employees who are, maybe dipping their toes into the water of EV investments, and they're just kind of wondering how they can get good information so that they can work with their local utilities more effectively.
I'll start that one out and just say definitely probably a big shout out to Department of Energy's Alternative Fuel Data Center. It's a great hub for all things alternative fuels. So, there's definitely a lot of information about electric vehicles, but they also have kind of any alternative fuel information as well. You can look and see where stations are in your state, also any kind of laws and regulations that are in place. Sometimes there may even be planning documents that you can look at. So I would recommend starting there. But I'm sure Kellen and Michael also have some other really great resources that are coming out of their organizations as well. Yeah,
one quick note to add there, Jeff. Yeah, definitely commend the Department of Energy AFDC site. We also did a white paper around how to think about plugging in your fleet, more from like a fleet operator perspective. But happy to share that maybe in the notes that get sent out afterwards. We definitely encourage you to reach out to your electric company, whether it's a IOU or a co-op or a muni. There generally are account managers or someone you can reach out to, particularly for larger customers like municipals, to ask if there's programs they can be a part of, or even just basic questions around, does this facility I'm looking at have the capacity I need to put in a bank of charging stations, right? Like, these are the kind of questions we want to keep encouraging, and as early as often as possible.
Yeah, I'll just jump in. Just, some of the groups like Western Governors Association, National Governors Association do webinars like this, and it's usually a great place to get orientated to all the acronyms, the alphabet soup that we all have. I'm sure if I said the acronym PSE, it probably means 50 different things for us in each state that are different. One of the programs that Kevin mentioned is the Legislative Energy Horizon Institute. I know they do 40 policymakers a year, and it's an Energy 101 course with the University of Idaho and the Department of Energy funding. But they APPA, if you have a municipal utility, it puts 3 or 4 people through that class per year. But there's lots of free content and kind of introduction to some of these topics that is accessible. And I'm not sure what's available on the WGA website, but some of the groups like the League of Cities, the Mayors Associations, they all have references out to some of these different products they put together for kind of onboarding folks into the world of EV jargon, I guess is the best way to put it. And I just want to talk a little bit more too about your experience. You did such a robust stakeholder process in Utah. And, I remember my early policymaking days when we were trying to figure out broadband access for rural areas. The only tool we had was to get the cable companies and the landline providers in the room and to ask them, hey, what do you have out there, and what can we do to augment what you have going on? And we had to form NDA arrangements to share that kind of proprietary information. Are there any lessons from your stakeholder process about what you can learn from the stakeholder community that would kind of onboard someone into exploring this world of EV policy at the city or county level?
Yeah, sure, definitely. I would say maybe the first lesson is to not have any assumptions and to, go into meetings probably thinking that, that you really don't know what's going on. And quite honestly, it's the locals who, know their town, know the ins and outs. However, maybe they aren't as familiar with what's going on with their the status of their grid. Maybe they don't know just how outdated some of the network could be. And that's where, if it's not just a municipal utility, then there might be that disconnect that's existed for quite some time. And, it's almost even kind of great that this electric transportation revolution is happening, because in a lot of ways, these stakeholders have been able to connect more and been able to kind of just plan better in all regards. I think it was mentioned too about planning for, the future of buildings and how, with EV construction, it's far easier to just have that incorporated into a new building design as opposed to retrofitting the old. And just simple conversations like that expose people to, oh yeah, I guess it would be a lot easier to not have to rip up all the concrete and go back and rewire everything. We may as well get this done when we build. And just little things like that have gone a long way with advancing more developments across the state.
Great. Michael, were you raising your hand? Go ahead.
Yeah, I just to amend what Annie was saying is, I think we're seeing here by talking to policy makers there, as well as potential owners of electric vehicles, particularly on the mid and heavy duty vehicle fleet side, is we need more standards. And this is something where states can really exert some of the purchasing power there, and being foresighted enough to say is, look, when we have new constructions, particularly state buildings, public buildings there, we need to make them EV ready, so that is parking lots need to have the conduits at the minimum. Doesn't cost, the incremental cost is close to zero, just laying the conduits, but it avoids just to cut open concrete and asphalt and reduces the cost. We need to be thinking about how do we standardize, particularly on the fast charging pedestals and technology, even the civil engineering aspects, right? So that we're saying is, how much concrete do we need to cut open? How high would they be? Is what's the access there for larger vehicles to get to? That those things need to be standardized, so that the permitting has to be reduced. We talked to a big fleet manager and they said, look, if I want to have 20 charging stations here, the utility told me that I need to put in my request there, and it'll take years to interconnect the charging stations there. And I think we need to speed this up. I think there needs to be cross-jurisdictional sort of standard or reference designs there, where states coordinate and saying, yep, we're buying into this. This is how it should be done. And then also on the communications, there's no, even on the plug, there is no standard design for larger than 450 kilowatt plugs. So if you're seeing a Mercedes or a Daimler, or you're seeing a Class 8 truck by Volvo or by Kenworth, it's all one-off, it's all prototype. Doesn't exist yet. So I think standardization there will help both on the electrical side and on the communication side. And this is something where states need to lean on and saying is, we need this in order to be future-proof.
Great, thank you. Kevin, do we have another question from the queue?
Yeah, this one was more of a comment, but the individual just said that, you know, they see a lot of potential for standalone batteries with heavy-duty EV charging, and as an opportunity to minimize impacts on the local distribution network. So I just wanted to see if maybe Kellen, you could take this one, if, you know, if your utilities see that as an opportunity, or if there are any sort of early case studies to highlight, or, you know, challenges that they potentially foresee with integrating those standalone batteries.
Absolutely, yeah. I think we're gonna have to get creative on some of this stuff, right? So I think Annie mentioned a great example. You want a DC fast charging station out in a national park somewhere, maybe not even a DC fast charging station, maybe just some level 2 charging. It might be a lot more expensive to try to bring, you know, 3-phase power out to that location than it is to add a stationary storage with some solar and like maybe a little mini microgrid set up there. I mean, there are going to be some locations, as Michael said as well, every circuit is going to be different. And there are some locations where we're going to have to look at some technology solutions to these situations. I think this is another good example is on some of these use cases where, you know, we're talking really high power charging. I just want to say to Michael's point around standardization, absolutely important. There is a group of companies moving toward a megawatt charging system. They're calling it, it's Charin is the group out there that's looking to standardize this, but they are looking at power capabilities that are in the megawatt plus range, right? And if you are trying to optimize for a situation where you're trying to get 200 miles of range back into a 500 kilowatt hour battery in 15 minutes, a time of use signal isn't going to be very interesting to a truck driver who's trying to just move on and move quickly, right, in 15 minutes or less. That's going to require, as Michael said, some upstream optimization. And I think one of those solutions might be stationary storage on site to help buffer some of these charging. So you could trickle charge, if you will, a large bank of batteries and then just you know, charge the vehicles really quickly in short durations when they come through. We're going to need to look at a lot of these solutions. I don't have great examples yet on that heavy duty side, but we do know some of these on the public charging for fast charging systems. A lot of those are being integrated with storage today. And that's more on a demand charge mitigation system, but I think we can look at that as a similar type of solution in some of these cases.
Yep. Annie, did you have a comment?
Yeah, just one thing to add on to Kellen's comments. The addition of a battery on a charging station can also provide a lot of resilience benefits. You know, maybe it's taboo to talk about off-grid solutions in a grid panel, but you know, there are definitely benefits for having a charger that can work during a potential blackout scenario, or you know, just thinking beyond some of those more remote stations where yeah, getting three-phase power is going to be quite a challenge, and we might just need to look at some of those alternatives. But even in cities, you know, we can find a lot of benefit for that type of technology to just kind of be more prepared in any kind of emergency situation.
That's a great segue, Annie. One of the questions I know that we've been asking in a lot of the forums like this is has anyone thought about, you know, what electrification for transportation resiliency looks like by design? Meaning, you know, it's probably going to cost more if you think about it after you're 20 years into building that infrastructure out versus doing it up front. And it's not that the solution is going to be, you know, necessarily all batteries, right? Because one of the questions when we started bringing it up that we get reflected back to us is, well, it's not just getting people out of an exigent situation, a wildfire, an earthquake, a hurricane, it's getting people back in afterwards when maybe the distribution system, you know, is a mess. How do you get people back in? So is it mobile chargers? Is that part of the resiliency strategy, is to be able to deploy mobile charging and batteries, or you know, some sort of renewable generation, green hydrogen, whatever? But are you all aware of any discussions about, you know, something you can hang your hat on, which is that, hey, when you get to 15%, you know, level 2 charging uptake rates, you got to have this much resilient charging available in cases of an emergency? Is there a formula out there? You've seen it all, Kellen. You are involved in probably more of these forums nationwide than anyone.
Yeah, it's a great question, Jeff. I don't think there is a simple formula, but the what you're getting at, I think, is really key. Is we need to define what that means, what resilience means in some of these, and that's going to vary by the use case, right? So I want to commend some of the work with our colleagues at EPRI, Electric Power Research Institute, doing a lot of technical work into what this means, right? If you are a transit operator, right, and you're going into all electric buses, and you're in a large, long duration power outage, what does your emergency route look like, right? You may not be operating all of your buses at all of your bus routes all the time under a, you know, multi-day power outage. That suggests some sort of significant, you know, event has happened, right? You may need 20% of your buses to be working at that scenario, right? And so maybe you don't need to plan for 100% resiliency. It's 100% resiliency for some fraction of your fleet, right? So we need to really understand what that resilience metric really is. But you're absolutely right. As we move toward more electrification as a fuel, we're going to need to also think really creatively about this. A lot of these transit agencies have emergency responsibilities to move people around, right, in outages and in other situations. So I think, again, microgrid style situations along evacuation routes, I think, will be interesting. I think mobile charging should be one of the solutions. Again, you wouldn't use that all the time, but if we're looking at a rare situation where there's long duration outages, I think that capability is appropriate. And just, yeah, there's a range of, I think, solutions here, but really defining what that resilience metric is going to be by use case will be really important.
Annie, Michael, any comments to that?
Absolutely. These questions are already on the forefront of big fleet owners to look at long-term outages, particularly East Coast, you know, with hurricanes. First responders there along the West Coast, they are all asking these questions, and it'll cost something. Resilience is expensive. It will cost something, and probably energy storage in a microgrid setting is one of the solution options. But it will need to be designed properly so that it can create some value, not only in these severe and extreme scenarios, but you got to optimize it so that they also provide some value even during normal operations.
Right, so mission critical and functional.
Yep.
Annie, go ahead.
Yeah, just one thing to add. So Utah actually put together a report on this topic, maybe not so micro-focused on just electric vehicles, but just using alternative fuels in an emergency, and how building redundancy into some of these emergency fleets is really going to just help us in dire straits, and being proactive about the planning to see how we can integrate alternative fuels into emergency planning will be really important. But then also incorporating the emergency planning into electric vehicle infrastructure planning. And that would be seen, yeah, like Kellen said, with evacuation route planning, and making sure that, you know, if the state has limited funds for building some more resilient charging systems that might have, you know, backup power as needed, that they're probably going to be prioritized along those evacuation routes, since that there could be multiple benefits realized from putting that type of off-grid, or theoretically could be off-grid solution in place if ever needed, but hopefully never needed. But like Michael said, everything does come at a cost, but there's also the avoided cost, which hopefully outweighs the upfront.
Yeah, absolutely. Hey, Kevin, I know we're getting close to our end time. Do we have time for one or two more questions?
Yeah, I think one more. I have one queued up from Michael, which comes from Spencer Reeder at Audi. And Michael, Spencer is just curious about, with the growing popularity of home installation of level 2 chargers, if that is likely to have significant effects on distribution networks, especially if, you know, many people are coming home from work and then all plugging in at the same time and using a level 2 charger versus a level 1 charger.
Yeah, so, and I think I was just peeking into his question there. So he was asking also for going right up to the maximum of the specified range of level 2, which can be up to 19.2 kilowatts. So 19.2 kilowatts is more than probably an average house will ever have combined, using electric hot water, cooking, cooktop, oven, and what have you. So if that were to occur, and if affluent folks there buy two Teslas, they already charge at 12 kilowatts each. So yeah, there will be challenges. I mean that we know this already. So you either need to manage it or you need to have some upgrades. So light duty vehicles, particularly with the interest of ever increasing a charge rate, even in the level 2 requirements, there will cause some upgrade requirements and creativity there by the industry to manage that load. And I feel very bullish by having talked to some startup companies that will do charge management with very little cost, using the existing telemetrics that Tesla, for instance, and Nissan already provide, and GMs, they all have that. Will provide load management solutions there that are cost effective.
Great, thank you, Michael. And hey, I just want to take a second and thank Annie from the state of Utah, Kellen from EEI, and Michael from Pacific Northwest National Laboratory. What a great panel of experts. I had someone that said that there was someone with SWAC, and that meant there was someone with actual knowledge. So we had 3 people with SWAC here today on the Western Governor's Call to educate us all. I just want to thank the great staff at WGA, Western Governors Association, Kevin Moss, the producer, Amanda Nelson, who makes us all actually show up and be heard, for her work, and for Western Governors for promoting this type of discussion. Kevin, I'm going to turn it back to you. Thank you for all your work in putting this together. And I'll give a virtual applause to all of our panelists.
Thanks, Jeff. And yeah, I'd like to return that note of appreciation to you for moderating, and obviously to all of our speakers. As I sort of teased during the introduction, this is our first webinar in a 3-part series. So we're all, in addition to looking at grid infrastructure, we'll also look at different financing strategies that can be used for EV infrastructure installations. And then our third discussion will look at workforce needs and opportunities in the electric vehicles sector moving forward, and how states can be helpful in, linking up in-demand careers to folks that are looking for gainful employment. So look for more information on those events on WJ's website in the near future. And this event will be posted on WJ's website and on our YouTube page, and then we'll also be providing a PDF of the slide deck on our website. And with that, everyone, thank you so much for tuning in and including some questions in the chat, and have a great rest of your day.